we're going to wait just a couple of minutes until we get started, wait for all of our attendees to join us. We've got some fun stuff in the works today. Should be a pretty cool program. All right. Looks like those numbers are starting to level off, so we can get started. All right, so I've already said this a couple of times now, so apologize for those of you who I'm repeating myself, but welcome to the Embassy Museum. My name is Nick Van Acker. I'm an educator here at the museum, and I'm excited to be showing you our Science on a Sphere program. We're talking about life without sunlight today. If you haven't been to an SOS program with us before, we'll go over just a couple of housekeeping things to get started. This is Science on a Sphere behind me, the big glowing ball hanging from the ceiling. Science on a Sphere is a project from NOAA, which is the National Oceanic and Atmospheric Administration. And there are about 170 Science on a Spheres all around the world. They all work the same way, which is really cool. It's just a big gray ball that hangs from the ceiling. And there are 4 projectors, 1 in each corner of the room. And those projectors project what we call datasets onto the sphere. So the sphere behind me isn't actually the Earth, it's just projected on to look like the Earth. It is an optical illusion. So I can pause it, I can move things around if I wanted to look at a different part of the Earth, and we can also look at all sorts of different cool data sets, which is what we're going to be doing today. If you guys do have any questions throughout the program or comments or anything, you can feel free to leave those for us using the chat function or the Q&A function. I'm joined today by my colleague Naja, who is our Science on a Sphere student presenter. And Naja is going to be looking at the chat and looking at the Q&A and making sure that your questions get answered. So anything you guys want to say throughout the program, feel free to let us know. I'm also going to be tossing questions out to you throughout the program, so feel free to participate in the chat. But with that, we can get started talking about life without sunlight. So there's a big planet behind me. I already mentioned its name, but just to get us started in the chat, I'm curious, do you guys want to let me know what planet is on the sphere behind me that we're looking at right now? I'll pull up the chat just so I can see some of your answers. But this should be just a gimme to kind of get the juices flowing, get us having a conversation. So I want you guys to type in the chat and let me know what planet this is that we're looking at behind me. And let's see, wait for a couple answers to roll in. I've got one answer there. Marybeth says that the planet is Earth. Yes, that is exactly correct. Good job, Marybeth. I'm glad that you know that one. Yes, so the planet behind me is the Earth. We're going to be talking a lot about the Earth today and talking about some of the specific things about the Earth. Earth is one of my favorite planets, but of course I'm biased because I live here. But one of the really cool things about the Earth is that humans have been on the Earth for a very long time, right? The entire history of the human race, we've been on Earth. But we are still learning new things about the Earth every single year, every single day. And so throughout the course of this program, we're going to be talking about some discoveries that happened in a part of the Earth that we don't get to look at that often. So I can actually pull up that part of the Earth right now. So the part of the Earth that we don't get to look at that often is, of course, the bottom of the ocean. So I pulled up this data set right here that shows what the bottom of the ocean looks like. And I don't know about you guys, but when I picture the bottom of the ocean, it's sometimes really hard for me to visualize. I usually picture it maybe as a flat expanse of sand, down there. I know it's really dark, it's really cold, but I don't know much about what's going on. But when we look at this map of the ocean, look at this map of the ocean floor, we can see that it's actually a really dynamic place. There's lots of different colors going on here. There's some darker blues and some lighter blues, and those represent differences in geography on the bottom of the ocean floor, or what we might call topography, which is the different heights. And so the floor of the ocean is a lot like the surface of land that we're used to seeing. There's mountains, there's valleys, there's ridges, there's canyons, there's all sorts of really, really cool stuff. But the crazy thing is, we didn't know this about the bottom of the ocean. We had ideas, but we didn't know this for certain until the 1970s. And that is when a group of researchers decided to map the floor of the ocean. And a specific group of researchers made some really cool discoveries. And we're going to be talking about those researchers today. So the researchers that we're going to be talking about in 1977 went to the bottom of the ocean using a submersible called the Alvin. These researchers were geologists and geochemists. And while everyone was mapping the bottom of the ocean, they were interested in learning about volcanoes at the bottom of the ocean. And so using Alvin, they went down to the bottom of the ocean to look for these volcanoes. Now, like I said, until this point in the 1970s, we did not have a good map of the ocean floor. So that brings up an interesting question. How did these researchers across the bottom of the gigantic ocean know where to look? So I'm going to pull up a picture right here, another data set. And this is going to look a little bit different. It's still our map of the ocean floor, but you'll see that I've added some little green triangles all over the ocean floor. And I'm curious if you guys want to put in the chat, what do you think these green triangles represent? If we know what these researchers were looking for, they were looking for something geological under the water that I mentioned. What do you think these green triangles might represent? All right, we've got somebody that says mountain ranges, and that is so close. We've got someone else that says vents. We're all in the right area. Those are totally correct answers. But Maribeth is totally correct when she says volcanoes. The green triangles represent volcanoes. But some of you guys are actually jumping a little ahead to what my next question was going to be. So all of these green triangles represent all of the volcanoes on Earth. And there's something really interesting about the volcanoes on Earth, and something that the scientists used when they were looking for volcanoes underwater. And that is that volcanoes follow a pattern about where they're located. And so you guys can see when we're looking at these volcanoes, especially the ones along sort of the edges of the Pacific Ocean, you can see that these volcanoes follow a specific pattern where they look a lot like they follow kind of a line that they go along. And somebody else, I believe it was Carol, said that they thought that the green triangles represented mountain ranges. And there's a reason for that. Frankie says I cannot see even a single green triangle. I apologize for that, Frankie. The resolution's a little bit low. This data set is actually also available on the SOS website. Najo might be able to put that in the chat so you guys can see the green triangles if you'd like to. But these green triangles do follow along mountain ranges on Earth. Not just mountain ranges, but they follow a lot of specific lines on Earth. You'll notice that there are some, for instance, mountains in Africa that have lots of active volcanoes, but also there are areas all along, like I said, the edge of the Pacific Ocean that have volcanoes. So some of those areas are mountain ranges, but the thing that they all have in common is that they're very active, whether it's active volcanically, active seismically, there's lots of earthquakes, and there's a reason for that. It's because of how the Earth works. So I'm gonna pull up another data set right here to show you guys what exactly is going on. And so you'll see that I pulled up a lot of different colored lines. And these colored lines represent the edges of something that are called tectonic plates or continental plates, which is probably something you've heard of before, especially when we're talking about things like volcanoes and earthquakes. These plates are all sort of fit together like pieces of a puzzle, and they come together to form the surface of the Earth. But these plates, of course, have edges. It's just like if you were putting together a jigsaw puzzle, there's going to be the center of the jigsaw piece, but there's also the edges of every piece. And on those edges, the magma that is underneath the plates are floating on, is a lot closer to the surface and is able to kind of bubble through. And so when these plates will bump into each other on their edges, whether they go underneath each other, whether they crunch into each other, whether they kind of dive down and go below, that magma is able to kind of percolate up through those edges, creating all of the volcanoes that we could see in our previous data set. So if these geologists were looking for underwater volcanoes, they knew that they had to go to the edges of a continental plate. They knew that they had to follow these lines of volcanoes, follow these mountain ranges, and theoretically, they should be able to find underwater volcanoes in those same locations. All they have to do is connect the dots and get to the next location. So that was their plan. These geologists got in the submersible Alvin, they dove down to the bottom of the ocean, and they started looking for underwater volcanoes. But something pretty crazy happened that they were not expecting. So I'm going to pull up a little data set here. I'll pause it for a second so we can see exactly where they were going. But these scientists decided to go to an area called the Galapagos. And you might have heard of the Galapagos before, especially if you're familiar with Charles Darwin. The Galapagos are a set of islands off the coast of South America. They're a really cool place for life, but also are right along a continental plate. So they decided to search in an area called the Galapagos Rift to try and find some of these underwater volcanoes. So they had a temperature sensor on the Alvin, and like I said, it's pitch dark at the bottom of the ocean. So they just had their temperature sensor out and were looking for areas of hot water, because hot water is going to mean there's volcanoes around. They searched for 2 years, But eventually, searching along the Galapagos Rift, they eventually saw a spike in the temperature on their thermometer, and they said, oh man, we found a volcano, and they turned on the lights to start making observations. They did find volcanoes, those are very cool, but they also found something else that they weren't expecting. So we're gonna dive down with the Alvin to see exactly what they saw. We're going down 2,500 meters, which is about 1.5 miles. And you'll see in some of these images, it might be a little hard to see because it is a little dark here, but these are the original images from the trip in 1977 down to the bottom of the Galapagos Rift. And you can see here, they were expecting to find volcanoes, but instead they found incredibly diverse life down at the bottom of the ocean, in the dark, in the cold, where no life should be existing. They were expecting to find maybe a few crabs, maybe a few shrimp, nothing too crazy. But instead, they found a diverse forest full of life, full of clams and crabs, and also these gigantic worms. And these worms are actually called riftio worms, and they're named after this mission to the Galapagos Rift, because this is the first time scientists had ever seen something like this. I have a model of a riftio worm here, just to show you guys the scale of how large these worms truly are. They are gigantic. They're about the length of your arm, if not even longer than that. And this is a little bit of a small one even. They can get even larger than this. So these riftio worms are absolutely gigantic. It's understandable for you to think, oh, they might have found a new species of bacteria, but there are gigantic animals living down there that we had no idea about. But this brings up a really interesting question as these scientists went down to this rift and found these new animals. One, they knew they had to bring a biologist next time so they could figure things out about these animals. But two, they had to answer a new question now. And that question is, how do these animals survive? They're at the bottom of the ocean. There's not a lot of food that gets filtered down from the bottom. If a fish dies at the top of the ocean, it might fall down, but that's not enough to support this huge, diverse amount of life. It's also pitch black, so the sun is not able to reach the bottom of the ocean. And we can show in another data set, the sun is really, really important, usually for how life forms on Earth. And so this is just some footage from a more recent trip. It's a little bit higher quality, so you guys can see some of the riftio worms. These are actually the worms spawning and reproducing, which is really, really cool to see that we have footage of that. But so I'll change this data set so we can see, we'll go back up to the surface and talk a little bit about how life usually works on Earth. So this data set is looking at plants on the surface of the Earth. And this is looking at plants on the surface of the Earth over the course of a year. So you'll notice there's going to be some fluctuations. Obviously, plants grow really well in the summer and die back in the winter. So you'll see that there are going to be some changes in the amount of green and yellow that we see. But for the most part, we can see that the surface of the Earth is completely covered in plants, both on the land and in the water. The water has things more like algae and phytoplankton, but they all contribute to the plant life on Earth. And all of these plants have something in common. And I'm curious if you guys want to leave in the chat what exactly that thing in common is that they have between the two of them. And I'll give you a little bit of a hint. These plants all use sunlight to produce their energy through a certain process. And I'm curious if you guys know the name of that process. It's again something you guys probably learned in middle school. It's how plants make their food using the sun. All right, so let's see if we've got some answers rolling in about how plants make their food. Yes, we've got one answer here that says photosynthesis. That is correct. Oh, somebody said osmosis. That's a good answer. Osmosis is how water moves through plants and through other things. But that's a good science word. I'm glad you remember osmosis. But yeah, so plants making their energy with the sun is photosynthesis. And if you have a hard time remembering that, there's actually a really easy way to break the word down. The plants use the light from the sun, which is photo. And the reason that word also comes from the same word as like photon. So there's lots of photons in the sunlight that the plants are using to synthesize their food. So photosynthesis, because they're using sunlight to make food. Yes, so all of these plants on the surface use photosynthesis to make that food. And the sun acts as kind of the basic layer of that, providing most of the energy. That provides the energy to the plants, which then photosynthesize to create food for themselves. And then those plants themselves end up being food for other animals, which are then food for other animals, and create this whole complex food web that we're familiar with on the surface of the Earth, thing we call the circle of life. So that's fantastic. That's how life usually works on the surface of the Earth. But like I mentioned, I'm gonna pull up a data set here that's a little bit boring. This is what it looks like on the bottom of the ocean. It is pitch black. If you don't have lights down there, you cannot see. No sunlight filters down there. So it brings up such an interesting question of, if we know how life usually works, we know that life usually starts with the sun and then plants making energy from the sun. If we remove that sun from the equation, how on earth do all these animals survive? And it created just this boom in the 70s of figuring out all of this new stuff about how life can exist in ways that had only been theoretical before, but now we had the proof sitting right in front of us. I'm gonna pull up another little data set that just shows a little bit more about discovery. And that is, as scientists were figuring out the answer to this question, how this life could survive, they were discovering more and more and more hydrothermal vents on the bottom of the ocean. So it might be a little hard to see here. You can probably see just a little specks. These are all red stars that are all over the surface of the Earth. And each of these red specks is the location of a hydrothermal vent discovery. There's also a little ticker going on the bottom of the sphere that, again, is probably pretty hard to see. But we started in the 1970s, and we are now up to 2011. So it's going to start off again in 1977 and go up to 2011. And so you can see that scientists consistently, every single year, were making new discoveries about hydrothermal vents, and with them, new discoveries about the life that lived at those vents. So I'm going to pull up a little picture that shows us more about how life can survive on the bottom of the ocean. And hopefully you should be able to see this at least a little bit, but I'm going to zoom in as well so we can look at it. So this is a model of a hydrothermal vent at the bottom of the ocean. And so we can see over all the way on the top up here, this is the vent itself. Move my finger at the right place. This is the vent itself sitting on the floor of the ocean. All of this blue stuff up here is, of course, water. And then down under here is the rock underneath the surface of the ocean floor. Remember that we talked about a little bit earlier in the program that all of these vents are occurring along rift lines, or along the boundaries between two plates, which means that that hot molten rock that the plates are floating on is really close to the surface at those boundaries. And so you can see all this molten rock down here below. And so these vents work in a really, really cool way, where all of the water that's down at the bottom of the ocean percolates down a little bit deeper through the rocks, right? It's not just going to be a flat surface that stops all the water. The water at the bottom of the ocean and the rocks at the bottom of the ocean are a little bit waterlogged. Same thing if you go to the beach and you dig down a little bit, there's going to be some water underneath the surface. So that water slowly percolates down, but instead of just filling an aquifer or just hitting a wall, instead that water ends up hitting all of this molten rock, all of this magma down here. This molten rock is, of course, very, very hot. It's literally melted liquid rock, which has to be at such a high temperature to get to that point. So water, being water, starts to get really, really warm. And that water would start to boil, except that it's under such high pressure that it's not able to turn into steam. So we get superheated water as it percolates down through this rock. And it gets to the point where it's 4 times the normal boiling point of water. It is super, super hot. Incredibly scalding. But as the super hot water percolates through the rocks, it doesn't just stay as water. It actually picks up little pieces of the rocks and little pieces of the molten magma that it's moving through. And it picks up all sorts of metals and minerals and things that ultimately end up getting pumped out of the vents. And so we can see that cycle where it goes through these blue arrows and then ends up getting pumped out through the vents, all this superheated water that's just super dense with metals and minerals that are pumping out of the top. Now, the really cool and crazy thing about this is that these metals and minerals end up being the base for the systems at the bottom of the Earth. Oh, I see a question that says this hot water is heavier. That is a great question. The water is not necessarily heavier. It is hotter, and hot things usually tend to rise. If you've ever been like in an attic in the summer in Michigan, you know that it's going to be really, really hot because hot air rises. Hot water also rises. So all that hot water ends up getting pumped out through the vent just naturally by the way that hot water works. But it is full of lots of dissolved minerals and metals. So those don't necessarily make it heavier the same way that like well water isn't heavier than distilled water, at least not that I know of, not in any noticeable way. But it's just packed full of all sorts of nutrients still. They're just dissolved teeny tiny. But these dissolved nutrients end up forming the base for all of the life that's able to survive at the bottom of the ocean. So instead of sunlight, instead of these things being photosynthetic, using the sun to make their energy, these start off being chemosynthetic. So they use chemicals to produce their energy. I see somebody else that says, asking if the water is denser. Yeah, so it's a little bit hard to wrap your mind around, right? Trying to figure out exactly how it works. And usually we do a demo actually in the room, and I did not have the demo prepared today, unfortunately, because I ran out of food coloring. You can actually do this yourself if you're interested. If you have a really tall vase or a really tall glass, you can fill that up with cold water, the same way that that water would be cold at the bottom of the ocean. And then if you have like a smaller bottle or a smaller, anything with just like a small mouth on it, you can fill that up with really, really hot water, put a couple drops of food coloring in it, and then you drop that smaller bottle into the larger vase, and you'll see that all the hot water ends up rising out of the bottle, the same way that a hydrothermal vent works. I wish that I had prepared that demo, but like I said, I ran out of food coloring today, unfortunately. It's really cool. And I believe that that demo is just available online. I don't know if you were able to find it, not just doing some frantic Googling, but it's a really fun demo to do to kind of wrap your mind around how all this water moving around works. But yeah, so all of the life down at the bottom of the earth is chemosynthetic, or starts out being chemosynthetic. Instead of there being plants at the bottom of the ocean that use sunlight to make their food, they're actually bacteria that use these metals and minerals to produce their own food, and they become the basis for all the other life to eat and survive with, which is really, really cool. I'm going to pull up this next data set here, and this is going to be a combination for us that shows the locations of the volcanoes and the location of the hydrothermal vents. And again, this might be a little difficult to see, but all this data set is showing is that these green triangles we were looking at before, all the locations of the volcanoes, are completely interspersed with all the little red stars we were also looking at. So the patterns are exactly the same. You can see that these hydrothermal vents occur where volcanoes occur because they occur via the same processes, which is really cool. I can pull up another data set now that we can look at. Remember a couple minutes ago where we were talking about how lots of different discoveries have been made for these hydrothermal vents, not just in the 70s, but up until the present. The really cool thing about these hydrothermal vents is that each location is pretty unique. And there's a good reason for that, right? If these locations are based off of all these chemicals and minerals and metals being pumped out of the ocean, the life that survives there isn't able to survive anywhere else. Even if you were to go, 60, 70 feet away, they wouldn't have that warmth and they wouldn't have that food source to sustain them. So each of the life at the vents can be similar, but it's still unique, which is super interesting. So I'm gonna pull up a couple of different sites all around the world to look at some of the different life at vents around the world. So the first one that we're gonna look at is called the Mid Cayman Rise. And the Mid Cayman Rise is located in the Gulf of Mexico, right below the United States. And we're gonna dive down about 2,300 meters, which is almost 1.4 miles. And we're going to see right now, there's a temperature probe on the sphere. You guys might be able to see, and that little gray or that little yellow blob is the Alvin. It's a submersible, or submersible from the Alvin anyway. I'm gonna stop this rotating so we can see it a little bit better. But we can see here that there is all sorts of life at this site as well. It might be a little hard to tell if it looks a little grainy on your screen, but all of these little things moving around are each individual shrimp. So this vent was just completely covered in shrimp. And these shrimp have a super cool relationship with the bacteria at the vent. So these shrimp actually act kind of like a host for the bacteria. The bacteria are getting their energy from the vent, pumping up all of these minerals, but of course the bacteria needs somewhere to live. So these bacteria live on the shrimp backs, and scientists are still figuring out what exactly the shrimp do with these bacteria, whether they just eat them directly to get nutrients, or whether the bacteria are able to provide the nutrients to the shrimp in some other way, whether it goes to their skin, or whether they pump it out into the water as little packets that the shrimp eat. Scientists are still figuring that out. But these shrimp are totally unique. You only see them at hydrothermal vents, which is really, really cool. So that's one site, the Mid Cayman Rise, looking at life down there. We're gonna dive a little bit deeper as well in this data set. This one will go down to about 5,000 meters deep. And this just shows a better picture of what some of these vents look like. This is one that's called a black smoker, and you can figure out why that is because it looks like there's black smoke coming out of the top of this vent. And all of that black smoke is the water that's full of nutrients and minerals and metals. So it's really cool that we have footage of that to see all of those minerals just being pumped out into the ocean for the life to live. Then there's one other location that we can look at right here. And this location is called the Mariana Back Arc. And this is in the Mariana Trench, which if you know anything about the ocean, you might know is the deepest location in the ocean at the bottom of the Mariana Trench. We're not going all the way down to the bottom. We're only going down 3,000 meters. But we're gonna look at another unique life form that lives down here. And again, this one might be a little difficult to see, but you might see some kind of gray blobs here that look a little bit like rocks. And these gray blobs are actually snails. And these snails are super, super cool. They're so cool, in fact, that scientists, being super creative, decided to name this site Snail after the snails. You can't ever give scientists credit for being incredibly creative when they're naming sites like this. But I have a model of one of these snails so we can see it a little bit better. So I can get right up close to the camera. You can see this is, of course, a 3D print of the snail. In real life, they aren't blue, they're black, but this is about how big that they are. And then I've got a little bit of a larger one as well, just so we don't have to hold it directly up to the camera so you guys can see this snail. But these snails are unlike any animal that scientists had ever seen before. These snails are just like all the life down at the bottom of the earth, or down at the bottom of the ocean, using the minerals and metals pumped out of the hydrothermal vents to give themselves food, but also to give themselves some protection. So this type of snail is what's called a scaly foot snail or a scaly foot gastropod. And there's a good reason for that, because if you look at this snail, you might be able to see that the bottom of the snail is covered in all sorts of little bumps, little scales. We're used to snails having shells, but snails also have another part to them that's called the foot that's down on the bottom. And this is a big muscular structure. It's what you see snails moving around on. It's how snails get around the world using their foot. But so these snails are special compared to other snails because these snails incorporate the metals and minerals coming up from the hydrothermal vents into their shell and into their exoskeleton, into the skeleton on the outside of their body. So they actually create these scales on the outside of their body out of a metal that's called pyrite. And you might have heard of pyrite before. It's also called fool's gold. But so these snails, when you look at them in life, and we might be able to see a little bit better here, they're kind of like a goldish black color. And that's because their exoskeletons are literally made out of fool's gold, which is crazy and something that we have never seen any other animal do. They are the only animals that we know of that do this in the whole world, which is super cool. And then just the last thing here that we'll look at in this program, I guess second to last thing, this data set that we're looking at right here shows the age of the seafloor. So as these plates are moving around, this isn't the main part of the program, but as these plates are moving around, they are constantly creating new surface of the seafloor. So anywhere that the plates are separating apart, that molten rock is coming up to the surface, and as it hits that cold water, it's eventually hardening. And that's what ended up creating the chimney that we saw with the black smoker, and also what creates new surface of the Earth. The surface of the Earth constantly gets replaced over millions and millions of years. So at those sites where it's spreading apart, it's creating new surface of the Earth. That's all the red areas. And as it gets to the cooler colors, to the blues and the greens, that's older areas that are the surface of the Earth. So those are areas that have been around for a while. They were created in these areas initially, but they've just spread out over time as new Earth has been created. So the really cool thing about looking at these hydrothermal vents is that not only are we making new discoveries about the life that lives there, making new discoveries about how life on Earth works, but it's also constantly generating new Earth itself, which is just amazing to think about. If you're looking for something exciting to study in science, you want to go to a place where things are constantly new, constantly changing. It's a really, really cool place to learn about. It's a really, really cool place to look at. We're going to look at just one more data set here to kind of bring us home. And you might be wondering, I'm hoping that you've had a good time learning about the life at the bottom of the ocean, but you might be wondering at the end of the program, why have we talked about this? Why are we so excited about learning about new types of life at the bottom of the ocean? And the answer might surprise you a little bit, but I'm going to pull up one more data set here, if I can find it. And that answer is Mars. So this is Mars, our red neighbor planet. It's very close to us, that we like to study a lot. I know that we just sent the Perseverance rover to Mars just a couple of weeks ago. But the reason that it's so important to learn about the life at the bottom of the ocean is because we constantly need to learn new things about life on Earth. So for the entire history of the human race, for the most part, we knew that life had to exist in only one way. We were certain that life could only exist by sunlight coming down to the surface of the Earth, by interacting with plants, plants creating nutrients, and then those nutrients fueling other animals. And we thought that was the only way that life could exist. Some people theorized it could exist in other ways, but we didn't have any proof until we made those discoveries in 1977. So now that we know that life could exist in multiple ways, that means that we can now think about all of the different ways that life could exist on Earth. We have to be constantly keeping an eye out and thinking about how those patterns are going to be affecting the ways that our lives work and how our lives are affecting those other patterns, those other methods of life. And if we're thinking about life really creatively, when we send missions to places like Mars, where we're looking for new life or evidence of old life, we can now broaden the scope of what we're looking for. If we had sent missions to Mars in the 1800s, which would be crazy, but if we had done it, then we would probably be looking for life the way that we just assumed the life had to be on Earth. We would be looking for plants, we were looking for animals that ate those plants. But now, knowing that there's life on Earth that we can physically hold and touch that uses chemicals to create its energy, when we're looking for life on Mars or evidence of past life on Mars, we can also look for the evidence of that chemical energy and maybe even other types of life that we can't imagine because we haven't discovered them yet. So making these discoveries on our planet, funding these discoveries on our planet is super important for not only looking for life on other planets, but also just understanding the life here on Earth and understanding that Earth is a much more complex, dynamic place than we might have given credit to originally. So that is the end of our program today, talking about life at the bottom of the ocean. I hope that you all had a great time. It's something that I love talking about. If anyone does have questions, I'm going to be looking through the chat. Naja, if you see that anybody has questions or thoughts, we can feel free to talk about those. But if you don't, you can feel free to head out at this point. Thank you so much for joining us today. We've got lots of other programs coming up, so you can feel free to check that out on our social media. We'll be posting all of those. We're also taking part in the Science Festival in April, so you can feel free to check out their website. You can just Google MSU Science Festival to see our programs and all of the other cool science programs that people on campus are going to be doing during April. So yeah, thank you all so much for coming, but I'm happy to answer any other questions that you all have. So let's see. Oh, thank you guys very much. I see a couple people saying thank you. Thank you guys for coming. I really appreciate it. Let's see. So if we do have any questions, I'm happy to answer them. Naja, do we have anybody tuning in with questions?
We did have Frankie ask for links, and they are now posted in the chat, just links to search up information about what we talked about today.
Oh, perfect. Yeah, so you can feel free to follow those links from Science on a Sphere. Oh, and I see you posted a Wikipedia article too. That's awesome. Yeah, so feel free to check those resources out. Let's see, we've got a couple people left. Yeah, all right. So yeah, unless anybody has any other questions, then we can feel free to wrap up here. But thank you all so much for coming out. Really appreciate it. Really love seeing the support for the museum, even though we are currently closed to the public. And of course, keep an eye for when we announce our reopening plans, which hopefully will be this fall. You can come back and see the Sphere in person. Right, but thank you so much for tuning in today. We really, really appreciate it. And we'd love to see you all at these virtual events for the museum. All right, have a wonderful rest of your day. Oh, we have a question?
Yeah, we do.
Yeah,
from
perfect.
Maggie asked about the San Andreas Fault.
Yes, that is a great question, Maggie. So Maggie asked about how the San Andreas Fault relates to this. And so the San Andreas Fault, I might be able to pull up a data set that's going to show this a little bit better. But the San Andreas Fault is what's called a fault line. It's named a fault. And so a fault is just basically a deep crack in the earth between two of these plates. The faults don't always come between two continental plates. Sometimes faults will come out a little bit. The Earth obviously is not perfect. It's nature, things are jagged and weird. So sometimes fault lines will appear within a continental plate, or they'll, kind of like crack out from the boundaries between two plates. But a fault line is just anywhere that two huge pieces of land are coming together. So the San Andreas Fault, as far as I know, isn't like volcanically active. There's no huge volcanoes, at least obviously in the area that's populated. But we do get a lot of earthquakes at that area. And the earthquakes occur for the same reasons that volcanoes occur, because those plates are constantly shifting around. So I believe the San Andreas Fault is what's called a transverse fault. I'm not a geologist, so correct me if I'm wrong, if anybody knows the actual answer. But I believe it's what's called a transverse fault, which is where they slide next to each other. So that ends up creating earthquakes where there'll be, a lot of pressure building up, and then all of a sudden the plates will just slide a little bit. So that's what ends up causing those things. So it's all related in the idea that they're all plates that are bumping up against each other or pulling apart. It's just different processes that occur between those plates. And then I see that we've got one other question here from Frankie. This is what happens to stuff put into the bottom of the Mariana Trench. That is a great question. Frankie, I'm curious if you can elaborate as to like what you mean by stuff. I know that there are some things that have obviously fallen all the way down there. I don't know if people trash. Okay, yeah, that's exactly right. Yeah. So I actually do have a really interesting data set here that we can look at about what happens to trash in the ocean. One of the nice things, at least, about trash in the ocean, not that there's anything nice about trash in the ocean, but one of the nice things is that at least it tends to float for the most part, unless it's really, really heavy stuff. Trash tends to float on the surface. We actually do have a data set about that. That's pretty cool. If I can find it real quick. And this is also available on the Science on a Sphere website, which is just sos.noaa.gov. And the data set that I am looking for, just stop talking for a second so I can focus on trying to find it, is a model that shows all of the trash that goes into the ocean, all of the different particles. Here we go. All the different particles that go into the ocean. And this is called marine debris. If it will show up for us. That's a movie. All right, so what's happening on the surface of the Earth right now, this is a model of what would happen if we were to distribute trash evenly across the surface of the Earth. So I can actually go back to the beginning just because I missed it. But you'll see at the beginning that the trash is distributed kind of evenly across the surface of the Earth. All these little particles exist. And then as all of the particles start spreading out, you'll see that they start to get concentrated in certain areas. And the reason for this is because of surface currents on the ocean, but also deeper currents that go underneath the ocean. We do a couple of programs about this. One of them is going to be the Mystery of the Penguin Feather program. So if you're interested in learning more about ocean currents, you can feel free to tune into that one when we do it. But you'll see that they form kind of these patches, these areas that all the garbage gets concentrated in on the surface. So if you've heard of the Great Pacific Garbage Patch, this is what caused that all the garbage that's floating on the surface of the ocean gets concentrated in a certain area of the ocean on the surface. Obviously stuff does sink down to the bottom. So it looks like Frankie said that he had heard, or they had heard proposals about putting toxic waste, like nuclear waste, into the trench. And that is super interesting. So the problem with that is that humans for a long time have decided that we can put trash in certain areas and it'll just go away, right? So that's the idea of a landfill usually, is that if we put trash in a landfill, we cover it up with some dirt, the trash is essentially gone away. And even if we have protections around it, if we have big rubber mats and we have tarps and we have everything that we cover it, the trash is still there. And so nuclear waste is harder. It's a lot harder to get rid of and a lot harder to break down. So I haven't heard any proposals about putting it at the bottom of the trench, but I would be very concerned about that. For the reasons that we talked about in the program today. Down at the bottom of the Mariana Trench, there are really interesting, unique life forms that we have not seen anywhere else on Earth. So it would be the equivalent of saying, oh, we can just go put trash in the Amazon rainforest because, there's nothing going on there. When in reality, I mean, that would be even worse because there are people that live in the Amazon rainforest too, but it's also an incredibly diverse place for plants and animals. We're saying, putting trash at the bottom of the Grand Canyon, putting nuclear waste at the bottom of the Grand Canyon. Just because the trench is down at the bottom of the ocean, people think it's really far away and don't think about the impacts that it might have. And we still don't really understand these systems. We have only known about it for the last couple of years. Like I said, from the 1970s, it's less than 50 years. So we're still continually learning about how these systems affect everything else on Earth. So it is a really interesting idea. And this is a complete side tangent, but there's some really interesting articles about how to get rid of nuclear waste and how we mark that for future generations, with the idea that if humans eventually go extinct, that nuclear waste is still going to be around after our extinction. And so figuring out where we can put it and how we can, not dispose of it, but how we can safely store it until it decays over time. So there's some really interesting articles about architecture and all sorts of stuff that we could use to mark that waste. Yes, exactly. Frankie says, like Sesame Street said, in someone else's yard. Yeah, it's a yard for somebody, even if it's just a yard for a worm. Somebody's yard, and we're putting the waste in. Yeah, that's a great question. That was really fun to talk about. All right, let's see. If anybody else has any other questions, happy to answer them. We're out here until about 1:30, and then we've got to sign off. But yeah, I'm happy to show other data sets too. If you guys are interested in seeing some other things that the sphere can do. We can look at all sorts of different stuff, from animal migrations to different planets, to looking at space, human impacts, we can look at weather. There's all sorts of cool stuff that we can pull up on the sphere to see if anybody is interested in seeing any of those things. I can actually, just when we're talking about nuclear stuff, and actually earthquakes too, I can show one data set that's really interesting and also is a little sad, but it is showing what happens when, you know what, no, actually I lied to you. I had two different data sets I was combining into my brain. We have one data set that shows the Fukushima Daiichi disaster in Japan, the nuclear reactor meltdown. But in my brain, I thought that we had a data set that showed how that stuff spread. We don't actually have that, but we do have one about an earthquake that occurred in Japan. That's what I was thinking. So apologize, I actually can't show that because it doesn't exist, but it'd be a cool thing to make. Yes, Rita asks, Nick, do we have any data sets on bioluminescence? So we do not currently have any data sets on bioluminescence, but I'm actually, we're working with a lab right now to create data sets about bioluminescence. And so those are in the works. We're looking at bioluminescent bacteria on the surface of the ocean. And it actually might end up looking a little bit similar to this data set where you can see all of the different blue sections. There's bioluminescence all over in the ocean. And so we're going to be looking at bioluminescent kind of like bacterial blooms on the surface that are called milky seas. And that actually is going to debut at the Science Festival at the Galad Lab station, which I don't know, Nadja or Rita, if you're able to post in the chat a link to your station. Science Hemisphere is going to be debuting those data sets at that point. And then we also should have a data set about fireflies, and then eventually we will be doing a program about bioluminescence. So lots of good bioluminescence stuff in the works. And then, then Frankie says, do you have any data sets on the African dust clouds coming across the ocean? I actually do. So I can pull that one up. This is a really interesting one. So this is going to be in our air section, and it is in the Aerosols map. So just got to find the right one here. So this is a really, really cool data set. We're moving on from the ocean. We're talking about the atmosphere now. But this data set is showing what we call aerosols in the atmosphere. And a lot of people look at this and automatically assume that aerosols must mean pollution, but that's not actually the case. Some of the things in the atmosphere obviously are pollutants that are coming from factories and coming from, wherever. But there's also a lot of stuff that naturally gets picked up and put into the atmosphere other than the gas that's supposed to be there. So those are things like sea salt, for instance, that gets kind of absorbed and lifted up into the atmosphere. And so all the sea salt on this map is the blue stuff that's moving through the atmosphere. Sulfates are in white, and sulfates are going to be those pollutants that are coming from factories and from cars. So we can see how those move around the atmosphere. There is what's called black organic carbon, which is just a scientific word for smoke. And that's going to be the green in the atmosphere. And then finally, what Frankie was asking about, the dust coming off of Africa is the red. And so we can see there's a really, really cool section right here where all of this dust, all of this red stuff is coming off of the deserts of Africa, Saudi Arabia, the Middle East, and going across the ocean. And it's slowly crossing over the ocean, and then it's landing in this area down here, which of course there's a little marker right above there. But it's landing in this area right here, which is the rainforest, the South American rainforest, the Amazon rainforest. And there's a really, really cool phenomenon happening here. You might think that, oh yeah, it's just dust that's being picked up from the desert. But this actually has to do with microscopic organisms as well. So a long time ago, before this area was a desert, it was actually covered in a lot of ancient lakes. And these lakes were full of these microorganisms that are called diatoms. And those diatoms are super teeny tiny, but they're just really densely packed with nutrients. They're just what we talked about, where they're kind of like the base level for the food chains in that area. Diatoms are still around in the ocean, in lakes, in water, everywhere. Diatoms are super cool. But as those lakes dried up, the diatoms, of course, died, sunk down to the bottom of the water, and eventually over time, they dried up a lot until they became deserts. So the really cool phenomenon that's happening here is that the wind is picking up these diatoms, these ancient microorganisms from the desert, and it's moving them through the atmosphere over to the Amazon rainforest. And these diatoms are full of nutrients. Even though they're dead, they're still packed with all these nutrients. So the dust from Africa, from those areas that's just full of these diatoms, is feeding the Amazon rainforest and is part of the reason that it's so diverse and so lush and so full of life. There's lots of different reasons for it, but that's one of the reasons, is that it's being fed by this dust from Africa. So there are really these global systems happening all over the earth. And same thing, if we put nuclear waste in the African desert and we didn't know about this relationship, we could be blowing nuclear waste over to South America. So yeah, we want to learn all about the different Earth systems. Yeah, that's a great question, Frankie. I love that. Yeah, if anybody else has any other questions, happy to answer them. Let's see, this one says, do we know what is in the air falling onto the Netherlands? I am not familiar with that. I'm not actually sure what is going on with that situation. Can you elaborate on that at all, Frankie? See what we can wait for an answer there to see what exactly is happening in the Netherlands. That's not something I've seen. Oh, okay. So just following the air currents, they're wondering about what's going on above the Netherlands. So I can actually pull up, let's see, we can look at the Netherlands on here. Make sure that I know what I'm looking at. And then I can zoom in on the Netherlands here, at least most of Northern Europe, and then I will pause the data set so we're not rotating around. Maybe, cool, there we go. So I'll zoom in a little bit on Europe so we can see what's going on the Netherlands. So it looks like for the most part, there's just sort of typical stuff that we would be expecting here in this area. There's lots of red stuff, which is the dust coming up from Africa. So it looks like there's some good nutrients going on there. There's also a lot of blue coming up from, looks like, the surface of the earth. That's going to be the sea salt coming from the ocean. And then there is some white as well. And it's important to note too, this is data that was collected in 2007. So this isn't necessarily accurate to what's happening right now, but it does give us an idea of these patterns. So it does look like there's some white as well coming from different factories. It looks like in North America, in Asia, and in Europe. But that, of course, is pretty common across the entire Earth. Frankie says the flow is a different direction than they expected. Oh, thank you for putting that in the chat, Nadja. Yes, so if you want to check this out closer and look at your own place where you live, you can look on the Science Hemisphere website and learn more about the different flow of nutrients all around the Earth through the atmosphere, which is pretty cool. All right, let's see. Any other questions or any other thoughts? One thing that I can pull up as well that's just kind of interesting that I was looking at here. Now, of course, I lost it. So hold on just a moment. I apologize for that. Just gotta find it. Oh, is that I was talking about diatoms a little earlier, talking about the surface of Africa. And this is looking at the diatoms that are currently living in the ocean on the surface of the Earth. So we talked about how the diatoms in Africa would be, sending those nutrients via the atmosphere to the Amazon rainforest, but those diatoms also exist all over the surface of the Earth, and at least in the oceans. And so then the different colors represent just different species of microorganisms that are living in the ocean. And some of these are diatoms. I believe it's the yellow are diatoms. So you can see there's just all sorts of cool life all over the surface of the Earth. All right, cool. So with that, I suppose we can wrap up if there are no other questions. But thank you guys so much for joining us today. We had lots of great questions, lots of great discussions, and I hope that you all enjoyed learning a little bit more about life at the bottom of the ocean and life all over Earth. Super fun to talk about, and I hope to see you all in person at when we do reopen for visitors at the museum in the fall. Cool. So thank you guys so much, and I hope you all have a wonderful rest of your days.